Hello everyone and welcome to examples for problem set number 4, fun with derivatives. So right over here you're going to be using the product rule. This is going to be implicit differentiation. This you need to take natural log of both sides. Implicit differentiation. So let's start with something like this one. Of course, I'm going to change the problem just slightly, but the idea is the same. How do you take the derivative of this? Well, you just take the derivative on the left side. That would be 2x. And do you remember what the derivative of sine is? That's right, cosine. Now, if I stop right there, I'm missing an important part because the chain rule says, hey, wait a second, you're ignoring this guy right here. So the chain rule would say, yeah, fine, you took the derivative of sine and got cosine, but you also need to take the derivative of the square root of y. And the derivative of a square root is 1 over 2 times that square root. And inside that square root is a y, so I also need to take the derivative of that, and the derivative of y is y prime. Okay, there we go. Now that I've done the derivative, I just need to do some algebra to solve for y prime. So I'll take this 2 square root of y and multiply it so that on the left side it becomes a 2x gets multiplied with 2 square root of y. So this has been eliminated. Now to get rid of this cosine thing, just divide both sides by cosine of the square root of y. And the only thing left on the right side is the y prime. And then I should simplify a little bit. For example, right here, 2 times 2 is 4x square root of y. And then you're working with your friend and they said, hey, for the answer, I got 4x square root of y secant of the square root of y. That equals y prime. There's my answer. And you're all, what? Where did this secant come from? Well, remember from trigonometry, 1 divided by cosine is equal to secant. So you could leave the answer like that it's divided by cosine, or you could get fancy and use this trig identity to say the answer is going to have times secant the square root of y. All right. Now number D, D's not a number. For number D, this is going to be implicit differentiation, but I want to do one like that because there's also some algebra fun for this one. So I change it to say x cubed. Now take the derivative on this side. That's going to be 3x squared. For the 12th time today, take the square root of, take the derivative of the square root, not the square root of the derivative, which is what my brain was trying to say. Take the derivative of the square root. That's going to be 1 over 2 times the square root. And then the chain rule says also take the derivative of y because that's inside the square root. On the right side, the derivative of y cubed would be 3y squared. And then take the derivative of y. Now right now I can hear somebody saying, wait, if this is y cubed and the derivative is 3y squared times y prime, and this is x cubed and the derivative is 3x squared, why isn't this times x prime? Well, it is, but the derivative of x, or in other words, x prime, means take the derivative with respect to x of the letter x. And that means that dx equals a 1. So you could literally say times x prime, which equals 1, so times 1. But that's not going to change the 3x squared, so you don't have to do that part. But when it's y prime is saying take the derivative with respect to x of y. And now this no longer says dx over dx equals 1. It means something completely different. dy over dx, that's y prime. Okay, now we need to do the algebra. We need to solve for y prime. And there's a y prime here, and there's a y prime here. So I need to get those two together and factor out the y prime. Now, the only part that's sort of troubling me is that this is going to have a fraction. And if I factor and I start dividing, then I'm going to have fractions within fractions. So I would rather just get rid of this fraction right now. So multiply by 2 square root of y on both sides. Perfectly legal algebra. So when I distribute this, there's going to be a 6. There's going to be an x squared, and there's going to be a square root of y. When I distribute this to this one, they're going to cancel. All it's going to leave is plus y prime. And on the right side, there's going to be 6. There's going to be y squared. There's going to be the square root of y and y prime. And for this part right there, that's already simplified. You do not need to like combine those in any way. The only thing, if it had like the square root of y to the 4th for some reason, well, a square root will cut the exponent in half. So if it had something like that, then you would need to simplify. But just by having this, you can leave it exactly like that. Now these two need to be put on one side. So I'm going to take this y prime and subtract it. So there was already that term, and then subtract y prime. And that means on the left side, all that's left is the 6x squared and the square root of y. Now over here, both of these have y prime, so I could factor that out. So factor out this y prime. When I factor this one out, it's going to leave behind a minus 1. And then just copy down the left side. And the last step is to solve for y prime. I just need to divide both sides by this thing. And this was the step when I was back over here and I got rid of the denominator. It was because of this step, because I knew eventually I would have to divide, and then I would end up with a compound or a complex fraction, and then I would have to simplify it. It's easier to just clear out the fractions like that step. Okay, so what's left is a 6x squared and square root of y now gets divided by this whole thing. 6y squared square root of y minus 1. And then I circle it. And then somebody's going to say, wait, Perkins, you didn't reduce, because look, you could cancel those 6's. But this term, so there's 3 terms, 1, and then 2, and then 3. And if you're going to cancel a 6, you have to cancel it here, and here, and here. But this one doesn't have a 6, so that means you can't cancel a 6. The same is true with the square root of y. This doesn't have a square root of y, so you can't cancel. So this one is actually done and deserves a happy face. Now on to something like this. So this has 3 functions. So there's the innermost function, which is the natural log of x inside the parentheses. Then that got substituted into the square function. And then that whole thing got substituted into a natural log function. So there's 3 functions, so you'll have to use the chain rule twice. I'm going to do one that at first you think, no, that's not the same, but, well, it's not the same, of course, but it's similar. Because this is saying, take an x squared function, substitute it into the e function, and then take that whole thing and substitute it into another e function. So it's actually similar. So taking the derivative, the chain rule says take the derivative of the e function, and the derivative of the e function is itself. Okay, now do the chain rule. So this got substituted into that e function. So the chain rule says now you need to take the derivative of e to the x squared. And the derivative of e to the x squared, well, the derivative of an e function is itself. And finally, I need to take the derivative of the x squared, which is a 2x. And that cannot be simplified in any meaningful way, so just leave it like that. So I took the derivative of this e function, it's that. I took the derivative of this e function, it's that. I took the derivative of x squared, it's that. So one at a time, I took the derivative of everybody, multiply them together, and then it can't be simplified. So it's done. What's next? Page 2. So find the smallest positive, so that cannot be 0. 0 is not a positive number. So that the derivative equals 0. So we'll need to take the derivative, put it equal to 0, solve for x, and have to find the smallest positive answer. All right, so instead of sine, I'm going to use cosine, and instead of square root, I'm going to use square. So here we go. So first up, take the derivative. The derivative of cosine. Yes, you're right. It's negative sine. So that's the derivative of cosine. Now the chain rule says take the derivative of x squared, which is 2x. Okay, so there's the derivative. Now set it equal to 0. And then solve for x. Well, because this is multiplication, you can separate these and say, well, 2x equals 0. But that would mean that x equals 0, and that's not positive. So even though that's an answer, I was asking for a positive answer. So then take negative sine of x squared and set it equal to 0. And I could actually get rid of this negative because I can multiply both sides by a -1. On the left side, it gets rid of the negative. And on the right side, if you multiply by -1, it still equals 0. So how to solve this? Well, if you look at the sine graph, and for the moment, I'm going to ignore the x squared. Just look at the sine graph. It looks like this. Right here is 2 pi, and right here is pi. So these are places where it equals 0. There's also this, which is 0, but again, it's not a positive number, so I'm not going to use the 0. So this one is actually the smallest positive. Now, if this just said x equals, I would just say x equals pi and be done. But because this says x squared, I have to say x squared equals pi, and then take the square root. So usually you put plus or minus, but again, I was asking for the positive answer. So just do the positive square root. So it's going to be the square root of pi. Now I want to use my fancy calculator and see if that's correct. So I will change the contrast and then graph the original function and make sure that it's in radians. So the original function was cosine of x squared. And then I'm zoomed in too much. Hey, do you see that right there? So it was graphing. So it's working, and I want it to stop. So I just push the on button. So that will stop it. And then I can do whatever I want, like zoom standard. Ooh, okay. I think I need to zoom in. So zoom in. That's a little bit better. So the derivative equals 0 right here at the bottom of this little trough. The derivative equals 0 right here. Now that we're on the positive side, this should be my answer. So this right here, right there at the bottom of that little valley, that's where it should be the square root of pi. So then I can go to trace and put the square root of paito. And yes, perfect. Good job, guys. Or gals, or whoever. Good job, calculator. You're smart. All right. So now I'm convinced that the square root of pi is the correct answer. It even gets a check mark. Got it right. And finally, for those that stuck around till the credits, find the equation of a tangent line and then use that to estimate some given value. So I'm going to do practically the same thing, but I'm going to use the square root of x. So first of all, find the equation of the tangent line for the square root of x function when x equals 4. So first, the derivative. As you may recall, the derivative of a square root is 1 over 2 times the square root. Now, I just need to plug in 4. So the derivative, when I plug in 4, is going to be 1 divided by 2 times the square root of 4. So this would be a 2 times 2 is 4. So it's going to be 1/4 is the slope. And then I need a point x comma y. So I know that x is 4 because that was given. And then for the y value, just plug that into the original function, and the square root of 4 is 2. Perfect. Now do the point slope formula. So y minus the y value of 2 equals the slope, which is 1/4, times x minus the x value is 4. And on the right side, go ahead and distribute this 1/4. So that will be 1/4 times x. And then 1/4 of 4 is 1, but because of this minus sign, it's going to be minus 1. And then last, add 2 to both sides. So it's going to be 1/4 x. And then if you add a 2, so positive 2 minus 1, 2 minus 1 is 1. So there's the equation of the line. So I've done this part so far. Now, plug in a 4.1. So this line right here will give you a good estimate for the square root of 4.1. So plug in a 4.1. So 1/4 of 4.1 plus 1 equals what? So 1/4 of a 4.1 plus 1 equals a 2.025. So that's my estimate for the square root of 4.1. What's the actual answer? The square root of 4.1 is 2.025. So at least for the first 3 decimals, my estimate is very good. So the actual answer, the square root of 4.1, at least to 3 decimals, is 2.025. That is a very good estimate.